Alright guys, so before this we looked into how we would solve a system of equations that looks like this by graphing. So we put both of these on a graph, we look where they intersect. It's a cool method, it works, but there's a way we can do this algebraically. And once again, we're going to get a solution. In this case, there's also going to be cases where, once again, we get infinite solutions or no solutions. But we're looking for the point where these two intersect, and we should be getting one specific point most times. So that point that we're getting algebraically, if we were to look at it graphically, it would still be the point where these two lines are hitting one another. So, how do we start this? We start the same way that we started our graphing problems. But in this case, it's a little different. So when we're graphing, we need to make sure both of these equations are in the form y equals mx plus b. Now, we only have to make it so that one of them is in the form y equals mx plus b, or we could also get x by itself. Either way, we just want to get one of these two equations so that we have a letter, either x or y, equals something. So we can take either of these equations. I'll take the bottom one. The bottom one's a little easier to get y by itself. So we have 4x plus y equals 8. And so to get y by itself, we just subtract 4x from both sides. We drop down y, we get y equals negative 4x plus 8. Now, what do we do with that? So we're trying to solve for a point where, or we're trying to solve for a letter. We're trying to solve for either x or y. And we can't really do that. Just by, maybe if you're a genius, you could just eyeball these two and see, oh, okay, that's the point. But most people can't. I can't. Just look at these two equations and see, oh, yeah, that's the point. So what you're going to have to do now is we're using the substitution method. So we have that y equals negative 4x plus 8. And so what we can do now is we can take this top equation, since there's a y in there, and instead of writing y, so in its place, so originally we have 3x minus, and then we have y. But we found here that y equals negative 4x plus 8. So in the place of y, we could put parentheses, and we could put negative 4x plus 8. And I'm going to underline that in blue, just so you can see that we're getting this from this right here. And then we still have equals 6. So immediately when I do this, you're probably thinking to yourself, why'd you do that? You turn this simple equation, it looks pretty simple, 3x minus y equals 6. That's not too complicated. And you made it something more complex. You added more numbers into there. And here's why I did that. This equation up here has both x's and y's. So we can't solve for one of them when we have two variables. However, if you look at this new equation right here, this green one down here, it has only x's in it. So we can solve for that. We just have to combine all the x's together and get the x's by themselves on either side of the equation, and we'll get x equals a number. And that's what we're looking for. So we're just solving this for x, using the skills we used a couple months ago. So first we need to distribute this negative into the parentheses. And so that gives us 3x minus 1 times negative 4x, which is plus 4x, negative 8 equals 6. Now, we have 3 terms on the left side, so that means 2 of them are alike. So which 2 of them are alike so that we can combine them? And you should be able to see 3x, 4x, they both have x's. So that gives us 7x, and we still have minus 8 equals 6. Remember, we're trying to solve for x. Let me draw my line in the middle, by the way, if this makes things easier. We're trying to solve for x, so we gotta get rid of 8. So we add 8 to both sides. We drop down 7x, we get 7x. 7x equals 8 plus 6, that's just 14. Lastly, we divide by 7. We get x equals positive 2. So that tells us that if we were to go to Desmos and put both these equations in on Desmos, we'd get two lines and they'd be intersecting at the x value 2. But that doesn't give us a solution. Our solution has to be the x and the y value they're meeting at. So now how do we use this x value to find the y value? And that's the easy part when we're doing this. You can choose either of these two equations, and what you're going to do is you're just going to replace x with 2 and see what y value you get out of it. So you could use either the top one or the bottom one. I'll use the bottom one in this case. So now we use x equals 2. And we're using the equation 4x plus y equals 8. So we're just replacing x with 2. Since we found the x equals 2, we're just replacing it with 2. So this really equals 4 times 2. We're just getting, since x equals 2 here, that's why we're plugging in 2 right here. So this equals 4 times 2 plus y equals positive 8. We multiply 4 and 2. That tells us 8 plus y equals 8. We're trying to get y by itself, so we subtract 8 from both sides. We get y equals, these cancel, we get y equals 0. Now we have our coordinates. So we have x is 2 and y is 0. And then our last step is we just got to put those two together and write them as a point. So our solution is 2